If a PN junction is doped with boron at a concentration of 1.5 times 10 to the 16th centimeters cubed, and phosphorus, so we have two atoms here, at a concentration of 9.7 times 10 raised to the 17th centimeters cubed, then what is the built-in voltage in milliamps for our junction? So we're looking for our built-in voltage in milliamps. So this is going to have to be 10 to the cubed, or this is 1 milli. Now this is for a junction, so if we look at the notes linked below like button, we're going to just do a control find and search for a PN junction. We can also assume that Ni is equal to 1.5 times 10 raised to the 10 centimeters cubed. And this is over centimeters cubed, sorry. And we also have a Vt value. So we're going to use this formula right here. The barrier voltage for the PN junction is more typically called the junction's built-in voltage. So in equilibrium, no applied voltage, the built-in voltage can be calculated from the PN doping concentrations. Also note that a higher Na or a higher Nd is going to equal to a higher VO because they are proportional to each other. VO is equal to, then we have these on top. VO changed slowly with doping due to the log function, or ln here. VO varies with absolute temperature, with the K, and it has to be at 300 K, due to the Vt and Nt. So we have our built-in voltage that we want to find here. We just have this formula. We're going to plug in our values. Now our Vt, it's given to us here as equal to Qt over Q at 26 millivolts at 300 degrees K. That's important to be at 300 K. And we also have our Ni, which is the 1.5 times 10 raised to the 10. And then we have these other two values, so our 9.7 times 10 to the 17 and 1.5 times 10 to the 16. Now this is going to be like our Na, and this one's going to be like our Nd. The order is not specific, they're just both our n's. And then our Ni is going to be squared in the bottom. So if we plug this into a calculator, notice how with this 26 millivolts, I excluded the 10 raised to the negative 3. That's because we're just going to want the answer in millivolts when we're done here. So I'll actually write MV here as well. So when we look at this, we're just plugging this in. And then for our answer, we're going to get approximately 827 as our result. So that's how we would go about solving this problem. We would just be using this equation for the built-in voltage.